So now let's talk about how average prices get incorporated into the definition of a put or a call. So these are examples of what's called average price options. Notice that we have a fixed K. So in these puts and calls, the strike price is fixed. It's the price of the security that's averaged and then inserted into the call or the put formula. So in an exercise of a vanilla call, instead of having an average GT, we would have the stock price of time T. Instead, with an average price option, we use the average price of the stock as of time T, and that's what we put into our standard put or call formula. And of course, these could also be defined with arithmetic averages, but these are the formulas for the geometric. We can also have what's called an average strike option, and here it's the strike that reflects the average price and not the value of the stock that's used in the payoff function. So we'll see that the form here is that the average is being used as a substitute for K. That's what we mean when we say it's an average strike. The strike price is reflective of the average of the stock prices. And again, once again, the average strike options can be defined with arithmetic means instead of geometric means. Interestingly, although the geometric average looks more complicated as a mathematical formula, because of the nature of Brownian motion and the nature of in particular, the assumed stock price behavior that we've seen on a binomial lattice and will later see in a stochastic process, because of the mathematics of those assumptions or assumed stock price movements, geometric averages lend themselves more easily to a mathematical analysis. So in fact, there are explicit Black-Scholes type formulas for puts and calls using geometric averages, whereas an arithmetic average, which looks much simpler, of course, mathematically is much less tractable, much harder, and must be solved numerically, typically with a binomial lattice or some other method. Here's an illustration of some prices, and here we look at puts and calls, average strike, and average price. So the first thing that we notice is that this is the Black-Scholes. When n is 1, that's the Black-Scholes price of a put or a call. N is 1, meaning we only use one stock price for the average price, namely the price at expiry. So that's the Black-Scholes call. Notice that if we define the average strike with n equal 1, then we're using a strike price equal to the average price of the stock, but we're only using one price of the stock, namely the one at expiry. So in this silly option, the strike price is equal to the value of the stock at expiry. So it always has value 0. We then increase n, and notice that when we look at the average price, that the cost of puts and calls drops. And let's understand why. Well, as we increase n, we are increasing the number of stock prices that go into the average, and therefore we're decreasing the volatility of the stock price that goes into the put and call formula. And namely, the volatility of the average stock price drops as n increases. And consequently, the price, because price is positively correlated with sigma, the price also drops. So that's logical. You also see for the average strike. Now here, this is an option where we use the actual stock price at expiry, which is time 1 here. It's a 1-year option. We look at the price at time 1, and we compare that price to the average stock price. So if we only use, and notice the pattern that as we increase the number of stocks that go into the average, the value of the option goes up. And the reason is that the As we increase N, the volatility of the strike price diminishes, and it becomes more certain that we're in the money or not. And you see that the increase in prices, where the K becomes less volatile, goes up. Not nearly as dramatically as the prices of the average price options go down.